Hey guys, it's often said that good features are what make or breaks models' performance. Feature transformation is a crucial step in the machine learning pipeline where we manipulate or modify our data features to improve the performance of our models. We have started a new series, a playlist of videos to understand everything about feature engineering. We have already seen data cleaning, imputation, and categorical encoding techniques in the last videos. Now we are going to talk about feature transformation techniques. If you're new here, I'm a mentor in the field of AI and machine learning. Started my journey long back 12 years before as a mentor, and during this time I got exposure to multiple technologies from Java to DevOps to Python to data science and also to AI. I have been helping corporates understand and implement applications, especially in Python, data science, and AI. As I've said, feature transformation is a crucial step in machine learning pipeline where we manipulate or modify our data features to improve the performance of our models. This video, we will deep dive and understand what is feature transformation, why and when to use feature transformation, different transformation techniques such as function, power, and quantile, etc. Understand their impact on the machine learning models, and for sure, we are gonna implement them using sci-kit-learn and Jupyter Notebook. So stay tuned for the next video as well to see the implementation of the same. So let's get started. Hey guys, welcome to AI with AI. This side, Asif Himnad. In the machine learning pipeline, after we get the raw data, 70% of the time is spent on data cleaning and preparations. And why do we do that? So that we can provide a quality data to the machine learning model, and hence we can have a better predictions. Quality of the data is directly proportional to the accuracy of the model. So a feature transformation is a technique by which we can boost our model's performance. If I want to define formally what is feature transformation, a transformation in which we apply a mathematical formula to a particular column, that is feature, and transform these values which are useful for our further analysis, and in turn we get better model performance. So in the machine learning pipeline, as you see in the image, a data preparation is what we are talking about. We already discussed about data processing and data cleaning. Now we are talking about the second part under data preparation, which is feature extraction. And after that, we are gonna see a feature scaling and the selection in future videos, right? So once we have a data prepared, we provide it to our model, to our machine learning model, so that it can give a better accuracy. And then we evaluate. If the predictions are not up to the mark, then we retrain, reiterate, and improve the accuracy of the model, right? This is what we keep doing. Then we finally deploy and monitor our predictions. But the question here is how feature transformation increases the performance of our machine learning algorithm. The answer is distribution of the data, which is not normally distributed, which has very large impact on the linear models like linear regression, logistic regression. So feature transformation is a technique where we use mathematical formulas to normalize these distributions, and hence it boosts the performance of our machine learning algorithms. Okay, before we proceed and discuss in detail, if you are new here, don't forget to hit that subscribe button and the bell icon so that you won't miss our latest videos on AI. We see you are watching our videos, but 90% are not yet subscribed. We put a lot of efforts creating these videos for you free. Keep us motivated by liking and subscribing, so YouTube algorithm will also help us reach more audience. So did you subscribe and like? Thank you. Now let's talk about what are the different types of transformations. So basically there are three types of transformations. First one is function transformer, second one is power transformer, and the third one is quantile transformer. So talking about the function transformer, there are three more subtypes if you see, and these are very much popular, right? So function transformer and power transformer are the ones which are generally used. And in function transformer, we have log transform, we have reciprocal transform, we have square transform. Don't worry about what are these different types of transform and when to use. I'm going to talk about that. But for now, let's just understand the different types, right? So under the power transformation, we have two different main types of transformers. First one is Box-Cox transform, and the second one, which is very much popular, is Johansson transform. Let's quickly talk about each one of these different types of transforms so that you understand and you decide when to use which transform. Talking about the very first function transform is a log transformer. What is this log transform? We apply log to every value of that particular column to make their distribution normal. So basically we are applying just a log to every value so that they become normal, and hence eventually this will give us the better performance of machine learning algorithm. Where to use? When you see a particular column has only positive values, because we know that log cannot take negative values. So it is used only for the positive values when data is positively skewed. And how does it work? Sometimes you see that columns has large scale than other columns. So you may see there is a huge difference between the scale of different columns, right? For example, in one column, let's say I have an age of a person, which is in numbers. Let's say 25, 26, 30 is the age. These are the numbers, positive numbers, and the other column shows weight of the person, but the weight of the person is in milligrams or even in grams. So the value in the grams or in the milligrams will be very large. 60 kilogram person is actually showing 60,000 grams, right? Value of the weight are given in the grams and age are given in numbers. Age of the person, let's say 25, and weight of the person is, let's say, 60,000 grams. You see a scaling problem here, and this is where a log transform can be applied. And what will happen because of this? It will help you put the data into the certain range, normalize the data, right? This is where log transformers can be used. So you can see in the image, before applying log transform, data is positively skewed, right? And you can see the QQ plot here. This QQ plot suggests the data is not linear, isn't it? So can I apply log transform here? So after applying log transform, I can easily see data is very much linear now. Data used to be curved or not scaled or not even distributed. Now it become linear. So definitely after transformation, the predictions which I'm gonna get will be more better for linear algorithms, isn't it? Okay. What is reciprocal transform, which is second type under function transform? This is useful when we have ratios. When we have positive numbers, we use log transform, but when we have ratios, we use reciprocal transform. Very simple. Basically division of two variables, right? So when should we use? If you have again a skewed data which is heavily skewed, having long tail of large values. So taking reciprocal of that can help normalize the distribution. Sometimes you also see the problem with the proportional relationships. Let's say we have two columns where one column is working hours and the second column is, let's say, family time. So if working hours increases, then definitely the time for family will be decreased. So this is what inversely proportional data. So when working hour increases, time to family decreases. So this is where you see a proportional relationship between the features. So whenever you see inversely proportional data, so because of this, biasness and skewing is natural to the data. And this is where we need a normal distribution. Then reciprocal transform can also be used to stabilize the variance. Particularly if variance increases, the feature value will also increase. So reciprocal transform will be helpful. The model which will assume the constant variance, right? Such as linear regression. We don't want higher variance. We need the stable variance. So that's why we can think of using reciprocal transform when we want to stabilize the variance. Importantly, when not to use the reciprocal transform. So reciprocal transform is not suitable for all type of data or in all situations, generally used for linear models. Apply this when you understand the underlying data characteristics, because there can be a potential issues that may arise. If your data has a division by 0 or close to 0 values, this can impact the effectiveness of the reciprocal transform. So make sure you understand the data first. Then only apply the reciprocal transform, because reciprocal transform is a ratio based transform. Okay. And here in the image you can see result of applying reciprocal transform. These are the QQ plots which you can see. This is before applying transform, right? Data is very non-linear. This is curve. I should make data linear, right? So when I apply this reciprocal transform, when data is ratio based and make sure data is not divisible by 0, then I can apply reciprocal transform. So once I apply that, data looks very much linear. You can easily see the difference between these two QQ plots here. In the next video, we are going to see the demo for the same, so that you can also apply, try yourself and see the results for yourself. Then there is a third type of transform under function transform, which is a square transform. So the name itself says, right? The square transform which computes the square of each feature value. So it just squares the value. Let's say if the feature value is x, then it converts that x into x raised to 2. It's just a square. So when should we use square transform? For non-linear relationships. So if you see, there is a non-linear relationship between a feature and the target variable, that is y column. Applying these square transform can help capture the relationship. It can enable a linear model to better fit the data, as it can model curved or quadratic patterns, right? So square transform is the best fit when you see a non-linear relationship between two different features. Or you see the scaling differences when there is a significant differences in the scale or magnitude of the features. And you know what? Sometimes squaring the values can help you balance out these differences and bring them to more comparable range. That is, it will help you normalize the data. And finally, square transform can also be used to stabilize the variance. So if the variance of the feature increases as the value increases, applying square transform can help stabilize the variance. Okay, how does square transform work? The squared values introduce non-linearity into the relationship between the features and the target variables. This allows for modeling more complex patterns and capturing curved relationships that a linear model might struggle to represent. So square transform introduce non-linearity into the relationship between the feature and the target variable. This is how it works. Or it does the magnitude amplification. Square transform amplifies the difference between the smaller values while compressing the difference between the larger values. So it boosts the smaller values and compress the larger values. This will help normalize the data, and this is what we want. And importantly, it will have a huge impact on the outliers. The square transform can magnify the impact of outliers, as squaring extremely large or small values can result in even larger values. This effect should be taken into consideration and handled appropriately. So make sure you consider the outliers if they have extremely large or extremely smaller values. And hence square transform cannot be the best fit if you have more outliers with bigger or the extreme smaller values. And again, this is where you see after applying the square transform. So before applying square transform, you see data is very much linear, right? This is a QQ plot. And after applying a square transform, you can see data is very much linear. So definitely after applying square transform on these type of data, the predictions will be more better. You can also observe the outliers here. So number of outliers are lesser here, but after applying square transform, the outliers value gets magnified, and that's why you see magnified values of the outliers here. Amazing, right? Definitely we'll see the demo again in the next video. Okay, so now we know all the function transforms. So we have seen log, reciprocal and square transform, what they are and when to use, right? And also how they work. Now let's talk about what are power transformers. These are really very easy to understand. Let me talk about these. So when do we use power transformers? Power transformers is used when the desired output is more Gaussian based, when we need more normal, distributed or proportionate output. And there are two types of power transformers that we have. The first type under power transformer is a Box-Cox transform, and the second one, which is more popular, which is Johansson transform. So when should we use Box-Cox? Box-Cox transform should be used when input data is strictly positive. This will not even accept zeros. Okay, so if you have positive data, then it is better to go for Box-Cox transform. And hence we have come up with the new idea or a new transform, which is Johansson transform. And I generally call this as an enhancement over Box-Cox transform. And if you have zeros or negative values in the data, Johansson transform comes to the rescue. So in this video, we have discussed feature engineering for machine learning and specifically the feature transformation techniques. When we are working with the linear model, it is necessary to normalize the scale of the data for the better performance. The feature transformation technique has a lot of variants available to do the task of normalizing the distribution. But at the end of the day, it totally depends on us what approach will best fit depending on the nature of the data. And that's how we come to an end of this video. If you have any questions regarding the same, let us know in the comment below. If you found this video helpful, please subscribe to my channel and hit the like button, and don't forget to share this video with your friends and the colleagues. Thanks for watching. See you again next time. Till then, take care and bye bye.